Today is July 22nd, 2015. Two assumptions that I noticed after reading many papers on this and coming to a conclusion. Now, I think a lot of geology is focused on the surface features of the Earth, and that's it, down to what, maybe at the most 100 kilometers. I mean, sure, you have your S and P waves that go through the Earth to find that the Earth was differentiated and it has a solid core. But I think for the most part, geologists ignore the core. And we'll see why. On my paper, I have written on page 12, I have yet to publish this part of the paper, the iron cores of the older stars and dead stars, planets such as Mercury, Mars, Venus, Earth, formed around the same time as their crusts. This assumption forcefully places the differentiation process itself as a quick, secondary, and unimportant process compared to the concept of plate tectonics, regardless if the core is a much larger, centralized object which gives the Earth its very structure and size. If anything, the crust received the majority of the attention because it is what we interact with. In other words, we interact with the crust, therefore it received the majority of the attention from geologists. A more reasonable, realistic approach is to look at the Earth itself as a vast, three-dimensional structure, and the crust is a secondary, if not unimportant feature in regards to the evolution of the Earth itself. The crust has its importance for the sustaining of life, that's obvious, but it is not the structure which the Earth relies on for stability. Imagine the Earth without a core. It would collapse upon itself. You need a giant centralized object to give everything else its structure and stability. So, to explain this, we need to explain how the core formed first, like the foundation to a house or a large skyscraper. Without a foundation, there is no house or skyscraper. As well, there is an absence of volcanism on older dead stars, meaning their cores remain, regardless if there is any plate tectonics at all. As well, plate tectonics itself does not account for the evolution of Earth during earlier stages, therefore is probably a vastly incomplete theory. Yes, it is vastly incomplete, and probably uses ideas which have no mechanism, such as what the driving force is for the plates to begin with. What's pushing the plates from side to side? Gravity's pulling everything down. So what causes them to go side to side? No geologist has ever answered that question. Number 13, that's the second one. The other assumption has to do with the idea that iron cores of evolved stars could form catastrophically, as in the iron catastrophe, and did not require many billions of years. And I wrote here, the iron cores of stars, because of their size and purity as evidenced in iron and nickel meteorites, take many billions of years to collect their material and solidify. The cores of stars take longer to form than the crusts, therefore the iron catastrophe is not a real event. As well, the sequence is wrong. The core has to form before the crust does. The crust is one of the last things to form. It's very young compared to the core of the Earth. The cores of stars form very slowly as they evolve, and core formation is a byproduct of stellar evolution itself, meaning as the star cools and dies and shrinks and the material solidifies, the iron and nickel clump together in the center of the star building the core, and that's what gives all the other elements something to layer on top of. It's that simple. All evolved stars contain iron-nickel cores. If the object does not have a core, then it is not the remains of a single star, but the remains of a collision event between other objects. Now, this is also brought into light. I remember going to the Smithsonian and looking at the rocks and minerals portion of their Natural History Museum. And as you walk in, to the space area where they have all these really beautiful iron, nickel, and chondritic meteorites, they had a giant solid three-dimensional block of iron and nickel, and they had it acid etched to where you could see the Thomson structures. That was the core of an ancient dead star that's been a piece of the core that's been wandering around the galaxy and probably came from outside of the solar system entirely. And there it is, sitting in the Smithsonian as if it's a, you know, just some random little rock. It just stinks how a lot of the other gems and jewelry type rocks and stones get a lot of the attention, and everybody that just saw the little iron and nickel meteorites sitting there, they just walk right past it. Okay, who cares? It's the core of an ancient star. It's a piece of a core similar to something as the Earth. Like, we can't dig that far down. So literally, it tells you what's going on down there. It tells you how amazing the entire three-dimensional structure of the Earth is. So in essence, these two assumptions, they completely ignore the incredible structure of the Earth. And I think that suits their mentality, because they don't want to focus on anything that doesn't actually harm their survival, so to speak. I mean, yeah, sure, scientists focus on, you know, stuff that really doesn't have anything to do with, you know, our survival. But at the same time, if you want to really understand nature, you have to realize that you're going to be biased towards ideas that are only towards your survival. I know figuring out the core of the Earth isn't very interesting and really doesn't concern us that much, but if you want to understand how the Earth formed, it should be your #1 concern. You shouldn't just brush it away as being some catastrophic event where iron just sunk there. What moved all the other materials out of the way? What caused the iron to heat up? Why is it so pure? Why is it a spherical structure? Why does it have all these Thomson structures in it? Why is it iron and nickel? Why? You know, they just ignore all of that. But, you know, I go over those two assumptions in this paper, and obviously I have around 7,000 words typed up so far, but I have to do a lot of pruning of it and editing. But today's July 22nd, 2015. Hopefully this helps people out to understand that the Earth is a much richer structure than what geologists give it credit for, as well as astronomers who outright ignore it altogether, not realizing they're standing on an ancient star older than the sun. But that's their problem, not mine. All right, take it easy.